Unit 1, Day 3, Distance and Midpoint Homework Tutorial. So in class, we discussed finding the distance and midpoint on a number line as well as a coordinate plane. So on this assignment, again, I'm only going to work out a selected few problems. Again, it's a tutorial to help you and guide you for the remainder of the assignment. Before we begin, the first thing I want to do is write down all the formulas we're going to need. The front side deals all with the number line, and the back side deals with the coordinate plane. So on the front side, the formulas we're going to need are the distance formula, which is point, the absolute value of point minus point. And the midpoint formula, which is point plus point divided by 2. So in the first 6 problems, they're asking you to find the distance. So again, please show me that you know how to apply the formula properly. So for number 1, I'm finding the distance, so let's set up my distance bar and my minus sign. Again, remember that's our skeleton, and that must be in the formula always, always, and always. So point E is at negative 1/2, so negative 0.5. Sorry, it's not going to fit in my, let me erase and make it bigger. So that's one thing you should notice on this homework assignment is that each line doesn't represent 1, each line represents half. So be careful when you're doing your work. So again, I'll draw my skeleton, have my minus. So now E again is at negative 1/2, or negative 1/2. G is located at positive 2. So now we grab our calculator. And again, it's math right 1. And now we type negative 0.5, which is the same thing as 1/2, minus 2. And that's going to give you a positive 2.5. So again, please show the formula every time. And always remember, distance will be negative. I'm so sorry. Distance will never be negative. All right, in the second section of problems 7 through 9, they're asking you to find the midpoint. So you're going to apply the midpoint formula. So in number 7, they want the midpoint of A to G. So draw your formula skeleton first and foremost, which is the plus in the fraction bar and the 2. And then put your points. So A is located at negative 4. G is located at positive 2. So now we grab our calculator, or do it in your head, whichever is fastest. So alpha y equals 1 for our fraction. And type negative 4 plus 2 uh, plus 2 divided by 2. And enter is negative 1. So the midpoint would be -1. In the third section, you're finding the end point because you're already given the midpoint. So, for those who need an illustration, I'll do number 11. On number 11, you have segment DN, where G is the midpoint. So again, because G is the midpoint, that means the distance from D to G is congruent to the distance from G to N. So I would first have to find the distance between D and G, and then once I know that distance, I'll also know the distance from G to N. So let's go back to the top of our screen. D is located at -2 and G is located at +2. So the first thing I'm going to do is find the distance between D and G. So draw my absolute value bars and my minus sign because that's the skeleton for the formula. And then insert -2 and +2. Let me double check. That's what I saw, right? Yes. And then you could grab your calculator or do it in your head. But at the end of the day, the distance is 4. So now what I'm saying is the distance from D to G is 4. So that means the distance from G to N will also be 4. So since G is located at +2, I would add 4 to that in order to know where N would be located. So that means N would be located at +6. Alright, so fractional distance was that set of problems that was 3 steps. So the first step, and I'm going to do number 15 with you, is to find the total distance. And we're going from 18 to 72. Okay? So the distance from point to point is first. So again, our point is 18 and 72. So the total distance between that is something with a 4. I believe 54. I'm pretty sure it's 54. Yeah. So the total distance is 54. Now you're going to find the fractional distance by taking 54 and multiplying it by 4/9 because that is the given fraction. And when you multiply that, I'm going to do this one by hand without my calculator. I know that 9 goes into 54 6 times, and 6 times 4 is 24. So the fractional distance is 24. And the last thing we would do, since we're starting at 18, and we're going to the right, we're increasing, we're going to add 24. So when I add 24 to 18, I would have 42. So 42 would be the final answer for that one. Now follow those same steps with number 14. Alright, so the back side of the handout deals with the coordinate plane. So the distance formula is the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. The midpoint formula is x sub 1 plus x sub 2 over 2, y sub 1 plus y sub 2 over 2. Now on number 17, the one I'll help you work out, they're only asking for the midpoint. So we're going to use the formula. Now write your skeleton out, which is the plus and the 2 twice, and then insert the numbers in the appropriate places. You have to add x's with x's. So one of the x's is negative 4, the other one is 2. So negative 4 plus 2. And you have to add y's with y's. So one y is 1, the other one is negative 5. So 1 plus negative 5. Again, I'll do this one in my head. So negative 4 plus 2 is going to give me a negative 2. 1 plus negative 5 is going to give me a negative 4. I'm sorry, I'll take it off the yellow. I know it's hard to read. And therefore, negative 2 divided by 2 is going to be a negative 1. Negative 4 divided by 2 will give you a negative 2. So the midpoint is negative 1 comma 2. Negative 2. And again, you have to write it as an XY ordered pair. And lastly, I'll help you with number 19, which again is the fractional distance problem, where those 3 steps are doubled by 2 because what you do to x, you have to do to y. So, first step, is find the distance between my x's. So have your absolute value bar, which is standard. And my x's are -5 and 3. So the distance between it would be 8. The next step is to find the fractional distance. So we're going to take 8 times the given fraction, which is 3/4. And I know 4 goes into itself and 8 twice, so it would be 6. And then lastly, you're moving in the direction from A to B. So our starting point is point A. And A's x value is -5. And we're moving here, we're at -5, 2. Right here, there's A. And B is at 3, +4. So since we're moving right, we're going to add. So we're going to add our fractional distance of 6. So -5, which would leave you with +1. So that's our x value. Now we do the same 3 steps to find y. So again, it'll be y minus y The y values are -2 and +4. So the distance is 6. Now we find the fractional distance. By taking 6 times 3/4, which would be 18/4, which would reduce to 9/2. And last but not least, A's y value is -2. Since we're going upwards, we're going to add the fractional distance of 9/2, or 4.5. So if I have -2 plus 4.5, I would end up with a +2.5. Let me double check just to be on the safe side. Yeah, gotta be sure sometimes. So that's our y. So the final step would be to write it as an ordered pair for technicality. So the ordered pair would be written as 1, 2.5. So I hope this tutorial was helpful. Please finish the rest of your assignment.